All right, so chemistry kids, we're going to do a lab today in which we're going to look at the reaction rate, especially the fire reaction rate of cellulose. And we're going to be looking at cotton essentially and how we can make it better flame resistant or react slower with flame. And so today's lab is called Save Zoboomafoo. And he's wearing pajamas on a fireplace. I want to try to make sure he's doing okay. So here on the desk, and you might not see me very well from here in a second, I have some cotton balls that represent cotton. And I have some balls that are tightly wound up. I also have some balls that are loosely kind of spread apart on there. And then what we're going to do is we're going to use a match. And we're actually going to light these on fire. And we're actually going to time how long it takes to react with oxygen in the air, part of the fire triangle, and see if we can come up with ways to slow down that reaction. So, very first thing we're going to do is we're going to do 3 trials of cotton balls that are just normal cotton balls and how long they react in the flame. So I have this ceramic weighing dish that we're going to use, and I'll kind of hold it just so you can kind of see what's happening during this process. I have a cotton ball. I'm going to put it in there. I don't know if you guys can see it that well or not, but we're going to use the timer. You can use a timer on the YouTube video itself, or you got to get a stopwatch. We're gonna time how long does this ignite in a day of flame. Okay, so you ready? Ready to take time? Put my goggles on. All right, I know you guys never see that. All right, so match. I'm lighting the cotton ball. Cotton ball is ignited. We're gonna time it. How long does it take for that cotton ball to stay lit? Still going. Still going. And it's done. So you see that smoke there, kind of letting us know that it's finished. All right, so how long did that take? Okay. All right. So I'm going to move that off to a different container here. Let it start coming off there. All right, so that was trial number 1. Let's do trial number 2 real quick. I got another cotton ball. Again, we're going to time it. How long does it take to burn a cotton ball that's all wound up there? Again, another thing you might notice is how flammable these cotton balls are. A lot of people are sometimes surprised by how flammable cotton is. It's actually pretty flammable on there. So again, it is still burning. Still burning. Use our stopwatch. Record how long it takes to burn. And it is almost finished, but not quite. We're getting there. And done. So again, you see that smoke, letting you know that it is finished. Right? Okay, so we're gonna put that off over here. We're gonna do it another time. So trial number 3, again, same type of cotton ball, bound together. Light that one on fire. It is burning. Again, this is part of the fire triangle here. You actually need 3 ingredients for the fire triangle. You need something that will burn, a fuel source. You need oxygen gas, which is in the air, and then you need a spark or something to actually start the flame with it. We're part of the fire triangle, and we're getting there. We're almost done, and it's done. So you see that smoke again. Okay, so that was 3 trials of cotton. Well, what I need you to do now is take the average of those 3 trials, and that will be our rate, our time of how long it takes for a normal cotton ball to catch on fire. Now, part 2 is going to ask us to spread the cotton out. So again, all I did was took a regular cotton ball, and I just fluffed it, and I made the strands in there a lot looser. Okay, so I'm basically increasing surface area. So I'm going to put that into our container here. And again, we're going to ask you to get a stopwatch or use the timer on the YouTube video. And let's see how different of a reaction that makes. So it's going. It's going. Still going. Still going there. It's almost done. And done. Okay. So time that one. How long did that one take? Oh no. All right. So we're gonna do another trial. Trial number 2. And ready? Time this one. Don't want to burn myself. And a little bit warmer this time. And we're done on that. Okay? All right. So let's dump that out real quick. And the last trial, trial number 3. So again, spreading it out a little bit here. You ready? Time it. And here we go. And we are almost done. And we're done. All right, so if you calculate the average of those, what happened between the cotton ball normal and the cotton ball all stretched out? Okay. All right, so the next part of the activity is actually thinking about how can we slow down the reaction regardless of what type of cotton we have. Could we add a chemical to it that will essentially what's called a fire retardant is to slow down that reaction and prevent it from burning so quickly. Now, granted, cotton is flammable. We just saw that. There's really not going to be any way to make it completely fire resistant. Um, there are different substances we can use, but in order to make cotton, especially if you think about children's pajamas, we are going to add some chemicals, and that's something you need to be aware of as a future parent. In order to make those pajamas, those clothing, just if they were to catch on fire, just to burn a little bit slower, so that you can take them off your child quicker and faster. And so one of the things we're going to look at here is baking soda. And so what I'm going to do is I'm going to take the regular cotton ball, and I am dusting it around, just putting baking soda around the cotton ball as much as I can. Okay. And so now I have a cotton ball here that has a bunch of baking soda on it. I'm going to put it into our container like we did before. Get the baking soda off my finger. Okay. And just like we did before, let's see if we can tell a difference in the reaction between a normal cotton ball Huh. You guys see that okay? Huh. Not wanting to burn. Let's try the cotton all stretched out. Let's dip that into baking soda. So again, I'm mixing it all up with the baking soda. Take it out. Stretch out cotton ball. Get the baking soda off my hands again. And let's try it again with the stretched out cotton. See what happens. Nope. I don't know if you can see that okay. We got a little bit reacting. So comparing that to this, again, you can probably try to figure out what type of clothing should we be using for children when we put a flame retardant onto cotton. Should it be something that's loosely put together, something like a mesh, or should it be something that's tightly bound together? Okay. All right, so the first two parts of the activity. The second two parts of the activity is looking at Alka-Seltzer. And so I have a couple pieces of Alka-Seltzer, and if you don't know what Alka-Seltzer are, they are or they are typically used for if you have a heartburn or digestion, things like that. Also if you have like a sinuses and you're all stuffed up, allergies, you can take this. Sometimes it kind of opens up the stuff. But anyways, I have a tablet. It broke on me, so that is going to be a factor in my reaction here. And I just got a film canister with a lid that's going to go onto it. And I'm going to mix these two together. And again, these are 4 big chunks. Okay. They were supposed to be 2 big chunks for the lab for the kids in the classroom, but mine accidentally just broke in a bunch of pieces. So put this on here. Let's see what happens. See stuff going on here. See some bubbling happening. Kind of leaking a little bit more than I wanted to. See how long that's going to take to pop the lid off. Sometimes they're just leaking a little bit more than I wanted it to. The next one I have, and I actually want to do this opposite directions. The next one I'm going to have is going to be a dry canister. Let me dry it out real quick because I did it wrong. The dry canister, I'm going to put in the Alka-Seltzer into here. This time I'm going to put the water in there. We're going to put the cap on, and we're going to see what happens this time with the lid. I got all over the place, all over the camera itself. But anyway, you can tell that that reaction is much faster, and that's kind of the whole point of the lab. All right. Hopefully that helps, especially for virtual kids. Hopefully that lab helped you out a little bit, and you can learn a little bit more from it with the camera off there. Okay. So if you guys have any question on the lab or the material itself, just let me know. But again, as we increase the surface area, the reaction went much quicker. I couldn't even put the lid on before it went all over the place. All right. That's the lab for today.